What you see here is a Razor E150 electric scooter. It's a 24 volt DC 100 to 150 watt motor, and it operates off two 12 volt batteries, sealed lead acid SLAs, and it's completely dead. Now you have your on off switch, absolutely nothing. And if you stick your charger in, and now tell me it's taken a charge, but I mean I've had it in for several hours and nothing happened. And if you twist the throttle, you'll hear the little clicking. So there's just nothing in. Let's upgrade to lithium ion. Now I've worked out, ideally you'd want about 21, so you're talking about a 7S 3P, and these batteries are from laptop packs and rechargeable vacuum cleaners. Let's get on with it. Now the board is held in with 1, 2, 3, 4, 5, 6 Phillips screws and 2 bolts which are size 4. So we'll deal with the size 4 first. Put them away somewhere safe. Now the last 2 Phillips, they have nylock bolts underneath, and it's a 8mm spanner you'll need. So just put that in underneath. Now we have another 2 4 Phillips. And there you have your 2 batteries. Again, as I was saying, they're 12 volts and they're 4.5 amps each. Now 24 volts will still only give you 4.5 amps because they're connected in series. And what we're going to do is then we're going to use these lithium ion batteries here. Now fully charged is going to be around 28 volts, possibly a little more. When they go under load, it'll actually drop down again. So I reckon, and adding up the amps on them, it'll probably work out at about 4.5 to 5 amps. So it should be comfortable enough. How long it'll last when it's running is another story. But if we can get it running and charging, that's good. If you stand them up, you'll see there then, this is your power into your controller, and then you have a link cable here which goes through a little safety switch. Now these are not spade connectors. It appears to be soldered on, so we're going to have to desolder them. In the meantime, what we'll do then is we'll just disconnect it there, and we'll pull it off this switch. And remove the battery pack. And we can put the scooter to one side for the moment, and we'll deal with the batteries. When we do the lithium ion, we're not going to need the safety switch. We'll just use this, and we'll use a 7S balance board. So it'll charge nicely. If there's a problem, it'll just cut out. Next thing we'll do is we'll have to cut off the want to save as much of the wiring as possible, and then we can desolder. So next now we'll have to do is we'll have to heat up our soldering iron. With the soldering iron heated up, the best way to desolder connections is actually to apply solder to them with the iron, and what it does is spreads the heat around and loosens up the solder that's already there. So ideally we should just be able to pull it away just like that. Now do the same with the others, and we'll be able to remove it all without having to cut anything. Now these two here you may not have much use for at the moment, well, not with this project. So batteries off to one side. Now this, however, you will need. Here we have our 21 lithium ion batteries, 18650s. So we have 1, 2, 3, 21. And what we're going to do then is we're going to connect them 3 in parallel by 7 in series, which will make up to 21. And then with the 7S balance board, that when you're charging then it should balance them nicely. Now these came from different appliances, be it laptop battery packs, and they were all spot welded together. As you see, they have little nibs on them. So what we want to do then is we just want to get a little grinder, like the little rotary tool, and just smooth them down. They'll be easier for spot welding again or soldering. So with the little tool, we'll just switch it up. And several minutes later they're all done, as if by magic. I forgot to mention that when you're doing it, wear eye protection. It's most important because there are little pieces that were left behind from the spot weld, the previous spot weld, that may flicker off, and you really need 2 eyes. Next step would be to join them together. And as I said before, what we're going to do is we're going to join them in 3 in parallel, which means we'll join positive, 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 and negative, negative, negative. Then the next ones will be from the positive. Again, these will be joined in parallel, but they will join then to these here, positive, negative, positive, negative, positive, negative, and so on until we have 7 sets, something like this. So 7 down by 3 wide, and that'll be your battery pack. So we'll get on with that. Now again, before I start, I tested out my spot welder and it doesn't seem to be up to it. So what I'm going to do is I'm going to solder them. Now the option would be you can spot weld them or you can solder them, but I'm going to solder them in this case. So that's the battery pack made up now. It's 3 in parallel by 7 in series. 1, 2, 3, 4, 5, 6, 7. 7 in series. I've also have fitted the BMS balance board, and before you start sealing it up, it's probably best to check the voltage. So we'll just switch it on there, and we have the negative here and the positive underneath. So we'll just stick it on the negative and the positive, and you see there 29 volts. Now check it through the BMS board, and again you can check from the positive here and the negative here, and you can see we have power. Again, check it up here and you can see it's working. Next thing to do now is to seal it up, and we can fit it. So there we have the heat shrink on it, and again, before you do go any further, check the voltage again. So we have it positive, negative, and we have 29.18. Now the balance board is plugged in, so what it's doing, it's already balancing the battery pack, and the batteries were fully charged before they were stuck together or soldered together. And then when they do charge, when it goes into charge, it'll go through the balance board and it should give an equal charge to all the banks of batteries. Now the next step would be to fit it back into the scooter. Right, here we go. Put it in. Now again, when you're making up the battery pack, just make sure that it's not too proud of the actual cover for when the plate sits down. You don't want it to be too tight and squash the batteries, or not tightened down at all. Again, now there's just one plug to connect, and there we go. Switch it on, and then just use the twist throttle. The little controller. Now it can only be one of two things. It can either be the little controller or the motor. And the easiest way to do that is to check the motor itself. And then if the motor is working, then we know it's a controller. To test the battery, just follow the wire to the motor, back around to the plug. Just undo the plug and you'll find two male spade connectors. Then connected to another battery, now it doesn't have to be 24 volt, it can be another, well, ideally not more than 24 to 30 volt, but it can be as little as 12 volts. So connect positive to positive, which is the red, and the black to the negative, and then just have a look here. Right, that tells us that the motor is fine. So it looks like it's the little controller. It just so happens that I have a 24 volt controller for brushed motors. And you can buy these online for as little as €8. And I had it for another project, but we'll use it for this one. And the plugs should be all pretty much the same. If not, there is identification on the plugs, so we can figure it out easily. So first we'll remove the battery. Again, just has the little tabs connected to each other, little blocks. And there we have the controller here, held in with two screws. Again, we'll just remove the connecting blocks. Everything should match up. If not, then we may have to make a couple of little, or remove the pins from inside, and we get a close up there. You can see there's little tabs. They just need to be pushed back and the pins can come out. Now, I'm not saying that we'll need to do this one, but if they're all the male pins are the same, they have the little tabs inside. You just push them back with a thin screwdriver and they'll just pop out, and then you can put them into the other plugs that are the correct ones. So, now the noise you were hearing when you tried the throttle sounded like a relay. You could probably open up the controller, get the number of the relay and replace it. And then this should just pop out if all the connectors are undone. So here we have it. I have this controller here. It's rated at 24 volts, which will allow up to about 30, which is pretty comfortable for the batteries there. It's a 250 watts, so it slightly exceeds the other one, and it works out at about 21 amps. The battery pack is about 4.5 to 5 amps, so we should be good. So let's connect that up. That's it now, we have it in. I did have to change a couple of the little connectors, the spade connectors, or at least take them from one plug into another. And again, so, and also the twist throttle didn't quite match up, so I replaced that with another one I had, which again cost less than €10. Let's just put the battery in. Let's just hook it up. And then with the power switch under here, we'll switch it on. Right, we seem to be, there's nothing fizzling and smoking. I forgot to mention these two here. One is for a brake light, which this little scooter doesn't have, and one here says it's for indicators, which would be your battery level or a display panel. Again, this scooter doesn't have. So it's switched on, and let's just see now. Now I'm just running it at low speed. I'll run it up. I did oil the chain and the bearing slightly, so there might be a splash of oil, but I'll run it up to speed. A little bit noisy at the moment till the oil gets into the bearings and lubes the chain up. So that's it. Now this E150 Razor scooter, it costs us €25. €8 for a controller. The batteries were taken from laptops and other cordless appliances. And the twist grip and, well, just the twist grip, that cost less than €10. So all in all, we're talking about 25, 35, 43, less than €45 to get what would have been a recycled, scrapped scooter back on the road so someone can enjoy themselves. Now they are rechargeable, and I've managed to put it back onto the connected to the original charging port. The original charger came with this. It's a 110 and 220 volt. So depending on the country you're in, it should work just fine. Now I hope this hasn't been too long and drawn out. I forgot to mention, before you put it back together, just get it into the right position you want, and you can pack it around with a bit of foam, and underneath, if you like, underneath the battery, as long as it doesn't come higher than the height of the cover itself or the little plastic box. Again, you can pack it up, bit of foam, bit of sponge, so it won't go flying around when you're out there enjoying yourself. Now it is rated for 8 years and up, and it's recommended that no one over 120 pound or 8.5 stone goes on it, but I'm a bit more than that and I'm going to give it a go shortly. And we'll put it back together now. And if you found this useful, give us a thumbs up, like, share and subscribe, and you'll find us on the usual social media platforms.